Now let's see what is empirical formula and molecular formula. But first, to begin with it, let's see what is empirical formula and how to calculate an empirical formula. Empirical formula is the formula of a compound which shows the simplest whole number ratio between the atoms of the elements in their compounds. For example, if I take glucose, the molecular formula for which is C6H12O6. The ratio, that is the whole numbers, 1:2:1. So the simplest ratio or the empirical formula will be CH2O. So glucose will have the empirical formula CH2O. Similar manner, if I take benzene, molecular formula is C6H6. Its simplest ratio is 1:1. So its empirical formula will be CH. Now how to calculate it? Let's take an example and understand it. To determine the empirical formula of a compound of sodium, sulfur and oxygen having the percentage composition sodium 29.11%, sulfur 40.51%, oxygen 30.38%. Weights are given in the bracket: sodium 23, sulfur 32, oxygen 16. Let's see the steps involved in calculation of the empirical formula. Step number 1. Write down the percentage composition and the atomic weight of each element present in the given compound. So you make a table in which the first column will be elements, that is sodium, sulfur, oxygen. The second column will be percentage composition, given to us 29.11% for sodium, 40.51% for sulfur, 30.38% for oxygen. The third column will be atomic weight. Sodium weight is 23, sulfur 32, oxygen 16. Now step number 2. Divide the percentage composition of each element by its atomic weight. The ratio gives you the number of atoms of each element or relative number of atoms in the compound. Example, for the element sodium, percentage composition is 29.11 divided by atomic weight 23. You will get the relative number of atom, and that is 1.266. Similar manner, sulfur percentage is 40.51 divided by its atomic weight 32. The relative number of atom is 1.266. Oxygen percentage is 30.38 divided by atomic weight 16. It will give you 1.898. Step number 3. Select the smallest ratio, that is among the relative number of atoms, and divide the remaining ratio by it to give you the simplest ratio of atom present in the compound. For example, the smallest among all this relative number of atom, that is 1.266 of sodium, 1.266 of sulfur, 1.898 of oxygen. The smallest one is 1.266. So divide all the relative number of atoms by the smallest. So we will get 1.266 divided by 1.266 for sodium. So it comes out to be 1. That is the simplest ratio, comes out to be 1. Sulfur 1.266 again divided by 1.266. Again it comes out to be 1. Oxygen 1.898 divided by 1.266. Answer comes out to be 1.5. Now whenever the answer is 1.5, multiply all this simplest ratio by 2. So sodium will become 1 into 2, that comes out to be 2. In case of sulfur, again 1 into 2, that again gives you the answer 2. Whereas oxygen 1.5 into 2 will give you 3. Therefore, the simplest ratio of sodium, sulfur, oxygen is 2:2:3. Therefore, the empirical formula is Na2S2O3. Chemical formula which represent the actual number of atoms present in a molecule of a compound. For example, if we take glucose C6H12O6, the molecular formula C6H12O6 represent 6 atom of carbon which is actually present, 12 atom of hydrogen and 6 atom of oxygen. Similar manner, if I take sulfuric acid, the molecular formula is H2SO4. So the actual number of atom present is 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen. Now let's see how to calculate the molecular formula. Let's take an example and understand it. To determine the molecular formula of a compound having the percentage composition, carbon 26.59%, hydrogen given to us is 2.22%, oxygen 71.19%. Vapor density of the compound is 45. In bracket, the weights are given to us as carbon 12, hydrogen 1, oxygen 16. The empirical formula of the compound is determined as already explained to you people. So, step 1 involves calculating the empirical formula weight from the empirical formula. Empirical formula of the above compound was calculated to be CHO2. That is, empirical formula weight will be 12 for carbon, 1 for hydrogen, 2 oxygen, that is 16 into 2, total comes out to be 45. Step 2, record the molecular weight or calculate it from the vapor density of the compound. Molecular weight from the vapor density. Vapor density is given to be 45. Therefore, molecular weight will be 2 into vapor density. That is 2 into 45. Answer comes out to be 90. Now step 3. Determine the value of n, an integer, by applying the formula. Molecular weight is equal to n into empirical formula weight. That is, n is equal to ratio of molecular weight divided by empirical formula weight. So n will be equal to 90 divided by 45. Answer comes out to be 2. The last step, 4th, calculate the molecular formula by applying the formula. Molecular formula is equal to empirical formula into n. That is CHO2 into 2. So it comes out to be molecular formula is C2H2O4. Now let's take a numerical which involves to find out both empirical as well as molecular formula. Let's take a question. The question is, a compound of carbon, hydrogen and oxygen is found to contain 40% carbon, 6.7% hydrogen and 53.3% oxygen. Calculate its empirical formula. If its vapor density is 30, calculate the molecular formula. In bracket, weight of carbon is 12, hydrogen is 1, oxygen is 16. The elements given to us are carbon, hydrogen, oxygen. So you make 5 columns starting with elements, percentage composition, third column of atomic weight, fourth relative number of atoms, and fifth simplest ratio of whole number. Let's take the first column. Element involves carbon, hydrogen, oxygen. Second column, percentage composition, carbon 40%, hydrogen 6.70%, oxygen 53.3%. Atomic weight of carbon 12, hydrogen 1, oxygen 16. The relative number of atoms involved 40 divided by 12, that is 3.33. For hydrogen 6.70 divided by 1, that is 6.70. For oxygen 53.3 divided by 16, 3.33. Now let's find out the simplest ratio. Out of the relative number of atoms, the smallest one is 3.33. So we divide the relative number of atoms with the smallest relative number of atom in order to get the simplest ratio. For carbon, 3.33 divided by 3.33 is equal to 1. For hydrogen, 6.70 divided by 3.33 is equal to 2. For oxygen, that is 3.33 divided by 3.33, that is equal to 1. Hence, the empirical formula of the compound is CH2O. Whereas, let's find out the molecular weight. For molecular weight, it is 2 into vapor density. Vapor density is already given to us. So 2 into 30, that is equal to 60. Whereas the empirical formula weight will be CH2O. So carbon weight is 12, hydrogen 2, oxygen 16. Why we have taken 2 for hydrogen? Because H is 2, H2 in the empirical formula. So 12 plus 2 plus 16 comes out to be 30. Now let's find out N, a whole number. It is the ratio of molecular weight divided by empirical formula weight. 60 divided by 30, answer comes out to be 2. So N is 2. Now molecular formula is empirical formula into N. That is CH2O into 2. So the answer comes out to be C2H4O2. Therefore, the molecular formula of the compound is C2H4O2. Now let's take one more question. And that is, state the empirical formula of each compound whose molecular formula is C5H10. Second, H2CO2. Let's take the first one. The molecular formula given to us is C5H10. Therefore, the ratio of carbon and hydrogen is 5:10. Its simplest ratio will come out to be 1:2. Therefore, the empirical formula for it will be CH2. The second part, the molecular formula given to us is H2CO2. Therefore, the ratio of hydrogen, carbon and oxygen is 2:1:2. Therefore, the empirical formula will be H2CO2 itself. Now, let's take some numerical which is based on chemical equations. What is a chemical equation? It is the balanced chemical transition reaction. In a chemical reaction, a rearrangement of the particles results in changes in the properties of the substances. Thereby, the properties of the product formed are entirely different from those of the reactant. All reactant or product in a chemical reactions are represented by a set of formulas, thus giving the identity of each element taking part in the reaction either as a reactant or the product. Information from a chemical equation which we get is, a chemical equations will always give a information regarding the molecular proportions, the relative mass, the relative volume if gases of the reactant and the products taking part in a chemical reaction. Let's see the procedure which is involved in solving the problems on chemical equation. Let's take an example and understand it. Calculate the weight and volume of oxygen at STP which will be evolved on electrolysis of 18 grams of water. Hydrogen weight is 1, oxygen is 16. Now let's see the steps involved in it. Step number 1. Write the balance equation of the reaction. The equation will be 2H2O will give us 2H2 plus O2. Step number 2. Find the molecular weight of each substances which is obtained by adding the weight of all the atoms in the molecules. Neglect the molecular weight not asked. The product of the number of the molecules and the molecular weight of each substance is written below the formula. That is 2H2O, 2 into bracket, 1 into 2 that is weight of hydrogen, plus 16 that is weight of oxygen, close the bracket. So 2 into 18, the weight came out to be 36 grams for 2H2O. Now on the right hand side towards the product, O2 that is 2 into 16, the weight came out to be 32 grams. Step number 3. 36 grams of water liberates 32 grams of oxygen. Therefore, 18 grams of water will liberate how much oxygen? Cross multiply it. You will get 32 into 18 divided by 36. Answer comes out to be 16 grams. Step number 4. The volume of the gas produced is calculated by multiplying the number of molecules of gaseous substance with 22.4 liters. That is 1 mole of a gas always occupies 22.4 liters at STP. Again write the equation. 2H2O will give you 2H2 plus O2. Now weight of water is 36 grams, that is 2 molecules, 2 moles of it is 36 grams, whereas oxygen which was 32 grams is equivalent to 1 mole of oxygen, and that will always occupy 22.4 liters at STP. Therefore, 36 grams of water will liberate 22.4 liters of oxygen at STP. Therefore, 18 grams of water will liberate how much oxygen? Again cross multiply it, will get 22.4 into 18 divided by 36. The answer comes out to be 11.2 liters of oxygen at STP. In case of chemical equation, there are two varieties of questions. One which will be based on weight and weight relationship, whereas other it will be between weight and volume relationship. Let's understand it with examples. To begin with it, calculate the weight of potassium nitrite formed by the thermal decomposition of 15.15 grams of potassium nitrate. Bracket, potassium weight 39, nitrogen 14, oxygen 16. Now let's see the solution part of it. The chemical equation for the reaction will be given as follows. 2KNO3 when heated will give you 2KNO2 plus O2 gas. Let's calculate the weight of KNO3. 2 into bracket 39 plus 14 plus 3 into 16 bracket closed, 2 into 101, whereas let's take the weight of KNO2, that is 2 bracket 39 plus 14 plus 2 into 16 bracket close, that is 2 into 85, 2 into 101, that is of KNO3, whereas KNO2 it is 2 into 85. Therefore, 2 into 101 grams of KNO3 yields 2 into 85 grams of KNO2. Therefore, 15.15 grams of KNO3 yields dash grams of KNO2. Cross multiply it. 15.15 into 85 into 2 divided by 101 into 2. Answer will be 12.75 grams of KNO2. Now let's take one more example. From the equation, calcium carbonate, that is CaCO3 plus 2HCl giving us CaCl2 plus H2O plus CO2. Calculate the weight of calcium chloride obtained from 10 grams of calcium carbonate and the volume at STP of CO2 obtained at the same time. In bracket, weight of calcium 40, carbon 12, oxygen 16, chlorine 35.5. Now the solution part. CaCO3 plus 2HCl will give you CaCl2 plus H2O plus CO2. The weight of calcium carbonate is 40 plus 12 plus 48, comes out to be 100 grams, whereas calcium chloride 40 plus 71 is 111 grams, whereas 1 mole of CO2 is liberated and 1 mole always occupies 22.4 liters at STP. Now first let's calculate for calcium chloride. 100 grams of calcium carbonate, that is CaCO3, gives 111 grams of calcium chloride. Therefore, 10 grams of calcium carbonate will give how much weight of calcium chloride at STP? Cross multiply it. Gives 111 into 10 divided by 100. Answer comes out to be 11.1 grams of calcium chloride. Similarly, 100 grams of calcium carbonate liberates 22.4 liters of carbon dioxide at STP. Therefore, 10 grams of calcium carbonate will liberate how much carbon dioxide at STP? Cross multiply it. 22.4 into 10 divided by 100. Answer will be 2.24 liters of carbon dioxide at STP.